Hello, and welcome to this edition of the CSIX podcast series. This episode will examine the challenges facing security within the ICT supply chain and discuss a hybrid framework to mitigate threats within the supply chain. Organizational supply chains are growing increasingly interdependent and complex. The result is an ever-increasing attack surface that must be defended. Security frameworks offer effective guidance to organizations to help mitigate their supply chains from attack. The increased use of third-party components has introduced foreign objects into the information technology enterprise. This includes human operators who are often given both on-premise and remote access to endpoints for their jobs, like troubleshooting support and information security services. With large-scale integration, an organization directly inherits another company's supply chain and potentially any security issues. Outsourced incident response teams, known as Managed Information Security Service Providers, install and monitor devices which often have unfettered access to an organization's most sensitive areas. If one of these security appliances was compromised, malicious actors could access the crown jewels of the monitored environment. Attacks involving the information, communications, and technology supply chain have occurred with regularity. One of the first well-publicized examples was the 2013 Target data breach. The credit and debit card information of an estimated 40 million customers was compromised. It was reported that the chosen vector was vulnerable network authentication mechanisms belonging to Target's third-party HVAC provider. A more recent attack showcased the ability for malware to be inserted into source code to be executed at runtime by high-level compiler libraries. These type of attacks are extremely complex in their preparation and execution, and favor those who have the resources at their disposal to conduct such coordinated attacks. Organizations tend to make a critical mistake in approaching the concept of information security. They attempt to monitor and defend all assets within the organization with the same level of criticality. An organization must look to how its goods and services are sourced and provided in order to defend their own unique supply chains. To address the vast ICT supply chain attack surface, various risk management policies will be examined. Research proposes that organizations must identify the critical components of its supply chain first, using NIST IR 8179 to accomplish this goal. Once these areas are identified, baseline SCRM practices must be established for them with ISO 28001. After the critical components have satisfactory defenses established, targeted controls will be identified using NIST 800-161. Finally, less critical components will then be factored into the business continuity plan and the disaster recovery plan. NIST IR 8179 Criticality Analysis Process Model was developed to help organizations conduct a self-assessment to identify their most critical assets and build defenses catering to their own unique needs. The ISO standard best practices for implementing supply chain security assessments and plans, was developed to establish and implement security strategies and techniques for an organization's ICT supply chain. NIST 800-161, Supply Chain Risk Management for Federal Information Systems and Organizations, borrows security controls from NIST 800-53, Security and Privacy Controls for Federal Information Systems, and impact analysis from FIPS 199 and 200, Standards for Security Categorization of Federal Information and Information Systems. These control families are structured from specific controls that are either directly related or are relevant to the supply chain risk management of an organization's mission or business processes. We will now examine a proposed hybrid framework methodology that utilizes a combination of guidance from the documents below and borrows strengths from each in successive order. We will examine 5 steps from NIST IR 8179. We first need to define a set of procedures that an organization can utilize to perform a criticality analysis. Next, conduct criticality analysis to define, review, and analyze the program to identify key activities that are vital to reaching the objectives of the program and the goals of the organization. Third, conduct criticality analysis where the system designer reviews and analyzes the system or subsystem from the point of view of its criticality to the overall organizational goals. Fourth, conduct criticality analysis where an engineer reviews and analyzes component or subcomponents from the point of view of its criticality to a specific system or subsystem of which these components and subcomponents are a part. Finally, conduct a detailed review where the program manager analyzes the baseline criticality analysis results to create a final criticality level for systems, subsystems, components, and subcomponents. An examination of the ISO 28001 Best Practices for Implementing Supply Chain Security Assessments and Plans will give the organization a roadmap to verifying or, if needed, adding security countermeasures to its critical areas. Section 5.3, Conduction of the Security Assessment, outlines the high-level approach to assessing the security of these areas. The initial assessment process guides the organization on how to evaluate suppliers. It is highly encouraged that vulnerability scans be performed in order to ensure a security baseline is established. Once the critical components are identified and a baseline of security is established, the main focus will now shift to the more detailed implementation of security controls from NIST 800-161. This is a robust, 3-tiered risk management framework that examines all areas that can be considered an ICT supply chain. The first of the 3 tiers is responsible for the parent policies. This tier describes control policies that need to be in place at the executive or organizational level. It is important that these policies are identified and mapped to their respective child policies. We'll now discuss the integration of the business continuity plan and the disaster recovery plan. The critical components identified in the evaluation Step 1 of NIST IR 8179, should be incorporated into a company's disaster recovery program. An evaluation of the business impact analysis on these assets is a vital component in demonstrating the need to protect an organization's critical components. This analysis will help demonstrate the potential monetary damages incurred in the event of a supply chain attack to these components. NIST 800-161 can be utilized for supplier trust audits. That document added the provenance control family to help track the traceability and origin of components in the ICT supply chain for both hardware and software. It is of utmost importance that security teams work with procurement teams to ensure that new components are only introducing a level of risk that is acceptable. Vendors should always be evaluated for their security practices before they are approved. Products or components which are under consideration for purchase should be evaluated by a risk management professional. An information security officer would be an appropriate person for this task. Organizations often submit questionnaires to potential business partners. Questions can be targeted to the suppliers based on the product type and integration point. The answers given should always be auditable and/or contractually binding. While steps to ensure integrity should be conducted as necessary, the integrity of an organization's critical components and management systems should be prioritized once an acceptable security baseline has been established. Then the priority should be placed on mitigating supply chain threats to other areas, undertaken in a descending level of importance. It should be noted that threat modeling can be used to determine the likelihood of an attack. At each point of a component's ingestion, it should be reassessed. Trusting and verifying integrity is a constant battle in the IT industry, but it is an especially challenging issue within the ICT supply chain. Both software and hardware need to be continuously re-evaluated whenever possible, especially given the various points of interdiction in the global supply chain. On behalf of the CSIAC, we would like to thank you for viewing this podcast. We hope you found the content useful and informative. If you would like to provide us with feedback, please comment on this video or visit our website at www.csiac.org, where you can also find additional content to review. Thank you.
Did you know that CSIAC offers free monthly webinars featuring experts in the areas of cybersecurity, software engineering, modeling and simulation, and knowledge management? Come see leading industry professionals talk about industry practices and leading research. Make sure to visit www.csiac.org/webinars in order to subscribe to our mailing list and see when the next webinar series is available. There you can also watch previous webinar series to catch up. Visit www.csiac.org/webinars.